If my hypothesis proves to be true, it will fundamentally alter our understanding of being alive. We're here at Mono Lake not just because it looks otherworldly and is an amazing, beautiful place on Earth, but also because of the unique composition and chemistry that is here at Mono Lake. In particular, we know there are lots of different kinds of microbes. And for example, this lake is very high in arsenic. So there's very well described microbes that breathe arsenate, a type of arsenic, like humans breathe oxygen. And there's also very unusual photosynthetic bacteria that do very interesting things with different kinds of compounds, not just like, for example, plants. But moreover, this lake, because of its high arsenic, will serve as a place that I may be able to test my hypothesis, as a proof of concept of an alternative life here on Earth, breaking away from CHNOPS, and potentially showing us a different way to make a living, substituting arsenic for phosphorus in the backbone of DNA. What might be our chances of finding a microorganism that could substitute arsenic for phosphorus? We have some candidate organisms right now in my laboratory that can grow and flourish with incredibly high concentrations of arsenic. So for example, in Mono Lake, there's about approximately 200 micromolar arsenic. So Mono Lake is about 40,000 times the amount of arsenic a human should ever be exposed to. So that number again was about 200 micromolar, 200 times 10 to the minus 6. We have candidate interesting organisms doing something very unusual that can grow with 40 millimolar. That's hundreds of times greater concentration of arsenic than what's in the lake right now. How they cope and how they flourish with that concentration, and they can grow even higher. Hundreds of thousands of times the concentration of arsenic that any known life we know of today can grow with. How they're coping with that, and notice I say coping, because our viewpoint is that arsenic could be toxic. How they're coping with that might show us something very interesting. I think I can convince my colleagues and the scientific community that indeed we may have a microbe that can do something wildly different in its DNA than we know of. The mechanism by which they do that will still lend insight and change our fundamental understanding of biochemistry.